Hello teammates, it's Mr. Nitty coming to you with another exciting episode from the Physics Bunker. I made this a title slide. I hope you like it. I designed it myself. Can you tell? I apologize for putting this up late. I've had a devil of a time getting these recordings done. I don't know. Camera issues, upload issues. So anyway, that's my problem, not yours. Here we go. We're going to look at FRQ 1 from yesterday. A little fluids interaction. It's going to let me address a couple points. And I'm selecting these based on what I've read in physics teacher message boards and what I've gleaned from the College Board on to best prepare us for the exam. So a little fluids. So we got a diver descending to a salvage ship. We're given some factors. Don't omit this. He's in or she's in salt water, so your density is different. Don't omit that. You're going to want this. Gauge pressure I'm going to talk about. Absolute pressure finds a rectangular plate, and we're gonna hoist it upwards at a constant velocity. Then we're asked if we accelerate it. Just qualitatively, we're not asked to solve for this. We're just asked, will the tension increase? If they want you to solve for it, you're going to have to defend your statement. If they want you to solve, though, they'll tell you. So, let's see. A couple things. When you're looking at these at our level, you're not going to have to worry about fluid drag. That's a second year physics thing. And I think that's good. Let's go. Well, let me caution that. You may, I doubt it, but you may be told what the drag force is. So I guess what I meant to say is you're not going to have to calculate the drag force. If you're given a drag force, you're going to treat that like a friction force. As you hoist it up, you would have that drag force acting down. Not to confuse you, just in case you come across that. So let's look. Let's look for gauge pressure. Let me take you through step by step. I hope it's okay that I read everything at once. I think otherwise it's just a waste of your time. So gauge pressure, we didn't really talk about it in the classroom, but I thought this is a great opportunity. So gauge pressure, let me take you through. So if you got something underwater, the pressure is not just coming from the water. You got the atmosphere pressing down on the water as well. So pressure atmosphere plus pressure water is going to give you your total pressure on your object. We're just going to rearrange that. So we're going to subtract the I'm going to subtract the atmospheric pressure from each side. So total pressure minus atmosphere is going to give you the pressure of the water alone, and that's your gauge pressure. Gauge pressure is what you want to measure just from that specific force acting on your object. When you check your inflation on your tires, you're checking the gauge pressure. You're checking the pressure of the air that's in your tire, not the pressure of the air in your tire plus the atmospheric pressure, right? Because that also applies because you got that atmospheric pressure pushing on the tire. So when you put the tire gauge on, you're measuring the gauge pressure. Similar here, where you want to know what the pressure from the water is. And you know that's going to be the pressure difference from the surface to the object. You don't have to write this part. I'm just taking you through. But it was one point to identify this, that pressure is the pressure, total pressure. Pressure, that's representing atmosphere, your original pressure, plus the depth you're underwater. That's in your equation sheet. So as you go through this, same thing I'm telling the AP Physics 1 team, be explicit every single step. Gauge pressure is this. State it, and then work forward. We're going to calculate the gauge pressure. It's simply the density times acceleration of gravity times the depth you're under the water. You're going to do some calculations. Again, I'm going to use 10 meters second throughout the next couple of weeks that we're preparing. If when you open that exam and it says use 9.8, use 9.8. It's all right. You're going to calculate that. 2 decimal places is fine. Don't get wrapped up. Is it 3.58, 3.59? They're not that specific. They just want to see you know what you're talking about, right? And pressure is force over area. That's just a reinforcement. Part A, 1, 2, 2 points. Easy money. Let's press on. Calculate the absolute pressure. Now, absolute pressure is, you'll also see total absolute same. Gauge plus atmospheric pressure. You calculated your gauge pressure. You're going to add your atmospheric pressure. Oh my goodness. Any easier, it would solve itself. 1 point. Part C. Part C, we're asked, calculate the tension in the cable if it lifts the plate upward at a slow, constant velocity. So you know, I think whenever you can, draw a free body diagram. There you go. Draw a free body diagram. I think that helps reinforce and helps you think through. You got force gravity down. You got 2 forces up, force tension and force buoyancy. Don't forget about your buoy force. And those forces are balanced. The net force up is balanced with the net force down because you're moving at a constant velocity. Constant velocity, no acceleration, balanced forces. I would be explicit. Constant velocity means forces are balanced. And walk the grader through this, the reader. Force tension plus force buoyancy equals force gravity. Isolate force tension. Force tension is force gravity minus force buoyancy. Then put your symbols in. And I would walk through like that and put your symbols in after you walk through. mg minus pvg, or rho, right? Rho, Greek letter rho. Teammates, that's 1 point for just identifying how you get constant velocity, forces balanced, why they're balanced, what the relation is. 1 point. Let's go. Let's go. We want now to make sure this is in the screen. We want to calculate the tension. We need a couple things to do that. We need the mass, and from that we can get the weight down, and we're going to calculate the force buoyancy. So let's do mass first. Density is mass over volume. Mass is density times volume. We're given the dimensions of the plate in the problem statement, and we're going to calculate that 0.06 meter cubed. We're given the density in the problem statement. I should have been explicit here because meter cubed is going to cancel. We're given density times volume is going to give us the mass. College Board likes you to put things in scientific notation. They're not going to deduct points if you don't. They may be a little queasy if you got some huge number and you write 7056135255 instead of putting scientific notation. But because usually when someone writes like that, it tells the reader, the student is really uncomfortable what they're doing. They've been trained in math class. You know, they've written 153.5 and they got it wrong because the answer was 153.3. So don't fret on that. So you've got your mass now. You want to you got to be explicit. That mass just can't leap on the page. You've got to calculate that mass. No miraculous answers. Calculate your buoyancy, your force buoyancy. You've got the density. Be careful again. It's in seawater. The density is going to be greater. You've got your density, got your volume, got your acceleration due to gravity. You're going to calculate a buoyancy of 6.15 times 10 to the second. You're going to now calculate the force tension. You got your weight minus your buoyant force. I could have saved a step there. 1620 minus 615, 1,005 newtons. And you could simplify that. 1 times 10 to the 10 to the third. You could simplify that. Almost done. Now we want to look at what's going to happen to the force tension if the object is accelerated upwards. Teammates, College Board wants you to do this. They want you to identify what you did earlier if you're asked about it later. So I didn't write this in a I just bulletized. I think bullets are fine. Unless they ask specifically for a paragraph length answer. And I think your second question on the AP exam is going to be a paragraph length. You got to write a paragraph. I think otherwise you can write in bullets. That's fine. As I explained in part C, force tension was determined for balanced forces. To accelerate must be an unbalanced force. To accelerate upwards must be an unbalanced force upwards. I think you got to be explicit like that. I don't think you're going to get away with saying to accelerate the force must be unbalanced. What is that? What? Acceleration's a vector. The vector direction is up in the positive y direction. Your net force must be in the positive y direction. It's good. Since the buoyant force doesn't change while object is totally submerged, additional force must come from the force tension. Identify why that is what it is. All right, teammates, I'm going to put this on the YouTube. Have a great day.